So today we're going to do a problem to find the migration rate and post-migration frequency of a population. And I know this is something we just did in class, but there are some common misconceptions with this too. So I wanted to try to get it now before you guys start doing it and mess up. Alright, so we're going to use the example we used in class with the banded water snakes. And what we're going to do is we're going to look at a situation in which population is not at Hardy-Weinberg equilibrium. There is evolution taking place, and that's because migration has occurred. And so the example we gave in class today was that you have a population of snakes. You have a big mainland or a big island migrating to the little mainland or little island. Usually go mainland to island. This is our mainland. This is our island. We know our allele frequencies for these islands. They're given or you calculate them. And if you need help calculating allele frequencies, please refer back to Hardy-Weinberg video number 2, how to calculate a basic Hardy-Weinberg problem. Alright, so I made these up, but basically, same issue we had before. What we're doing is we're looking at the recessive allele for unbandedness in the mainland population and the island population. And we want to look at migration rate here. And so we want to focus on this allele, this recessive allele, and look at how migration rate is affecting it, the frequency of this allele, before and after that migration occurs, basically. So we know our allele frequencies in the populations before migration occurs. These we calculate or they're given to us. First thing we want to find is migration rate. What we need to know to find migration rate is the number of individuals that are migrating, so leaving the mainland and going to the island, and the number in the population after migration, so in that island population. So we know some number leaves the mainland. We don't care how many were in the mainland to begin with. Some number leaves the mainland. They come to the island. We want to know what proportion of these island individuals are from the mainland, from just this past migration time, or on average, over all migrations. So the numbers we had in class today, we used 12.8 snakes. Can't have 0.8 of a snake, so clearly that's an average over years. 12.8 snakes, on average, migrate. And our island population was 1,262, I think. Something like that. That's how many are on the island. So our migration rate, to find that, we would just do m equals 12.8 divided by 1,262, which is about 0.01. So about 1%. Okay? Now we have a migration rate. So we know that about 1% of the population on this island is made up of migrants. They're not locally adapted. They're from that other population. Alright, we're going to save that. Now what we want to find is the change in allele frequency for that recessive allele in the island population post-migration. So now what we want to do is we want to find three things. We want to find the post-migration frequency. of the recessive allele in the island population. So post-migration, so after that migration occurs. So we're only finding one thing, but those are 3 key pieces of information that we need to know. So post-migration frequency of recessive allele in island population. So we want to know this little b, after these 12.8 snakes come over, what does it change to? This is pre. This little b is pre-migration in both populations. All right? And so to do that, we do that equation with the delta in it. It's actually intuitive once it's explained. Delta Q or delta P, it doesn't matter because it's an allele. So if we're looking at the dominant, we can say P. If we're looking at the recessive, we can say Q, but it doesn't matter. You could also say delta little b. So here's our equation to find the change in allele frequency. Delta Q, so the change in allele frequency, is equal to the migration rate times the allele frequency of the population the migrants are coming from, minus the allele frequency of the population the migrants are going to. So this is where people usually get confused. They don't know which one is Q2, which one is Q1. So it's always Q2 minus Q1. Q2 being the population they came from, the allele frequency, the population they came from before migration. Q1 being the allele frequency of the population they're going to before migration. And the way I like to remember that is Q1, we always want to know, what we want to know about is number 1. We want to know about the island's Q1, right? We want to know where the individuals are going and how that affects the allele frequency after they've gotten there. All right, so this is just plug and play. Now that we have our migration rate, we already know our allele frequencies. They were given to us or we calculated them earlier. So you do change in Q is equal to 0.01 times 0.15 minus 0.4. Now some of you are probably going, oh wait, Amanda, that number is going to be negative. You're right. It can be negative because it's a change. It's a change in allele frequency. And that frequency can either increase or decrease. That allele frequency can either increase or decrease. So when we calculate this out, you get a really small number. Negative 0.0025. Alright? And it's negative. That means that this allele frequency is decreasing. It's smaller after migration has occurred. Most people stop here when they turn in the homework or on an exam. Do not stop here. Common issue number 2. This is not what the problem is asking for. This number we just found, delta Q, this is change in allele frequency. The problem is asking for post-migration frequency of the recessive allele in the island population. So what you need to do is you need to use this change in allele frequency, delta Q, that we just found to find what that post-migration frequency would be. And that is actually really, really easy. You take the pre-migration frequency, which is 0.4, old, we do the new. So new is equal to old plus the change in delta Q. So that's easy, right? Think about it logically, not mathematically. Think about it in terms of words. So the new allele frequency after migration to the island is going to be the old allele frequency of the island plus that change in the allele frequency. And because it's negative, it's plus and minus, so it's actually subtracting. So this is 0.4 minus 0.0025 0.3975. So our new allele frequency post-migration for the recessive allele on the island is 0.3975. And so the recessive allele is slightly lower in frequency. That's it.